1.1b is on sets and interval notation, which we have done before, but we're going to learn a little bit about the IB way of doing it. So we've seen this before, previous knowledge. X, and we read this little bar as such that x is less than or equal to 5. So we know what that looks like when graphed. And what we've done in the past is we've said, well, if it's less than, it goes to negative infinity. And then we do a soft bracket here to say not included. And then we do a hard bracket to do included. But of course, IB likes to do their own thing. So they use a hard bracket facing away for not included, and then included is still the same. So you'll always have hard brackets, and it'll be included or not included based upon whether it's opening away, not included, or opening towards the number, which is included. Okay. This is a little cheat sheet to help you with some of the different notations. You may want to copy all these down. You may be able to intuit what you've already learned and then quickly connect with the hard bracket, soft bracket. But if you'd like to connect that, you can. So this little funny thing here is element of. It looks like an E sort of. So X is an element of the numbers between A and B, where A and B are included. Okay. You can take a second and scan through these. If you'd like to pause it, you can. So for example, X is an element between the numbers 5 and 88, both included. Here we have X being an element between 0 and 2, and stop and think about it. Included, not included. You can give this one a shot on your own. Sometimes number sets are defined kind of in a funny way where we're looking not at just every single number between those, but we're looking at the numbers where we're only interested in like the odd numbers between something, or the even numbers, or just the integers, or just the rational numbers. So we can define those using some of the symbolic statements from before, including the categorizations. So if I wanted to talk about the integers between -8 and 6, but not including -8 and 6, I can say that I'm talking about x, such that x falls between -8 and +6, and then we say where x is an element of z. Well, z is just integers, right? So we're not talking about anything between 5 and 6, right? We're just talking about 5 to 6, or whatever the case may be. If you want to give B and C a try independently and then check what you did against the answer, it's a good way of checking to see how you're thinking about it. You can ask questions about anything when you come to class the next day. I've seen kids take and put sticky notes on their notes. I have a question about, and then they can come to class ready to chat about this. The next thing we're going to look at are sets and some of the symbols associated with sets. So we have this notation right here. If you want to copy that down into your notes, you can. If you want to pause and then copy, you can do that, but we're going to keep going. Okay. So we're going to look at the set between 1 and 10. We're going to call that our universal set. So everything in between 1 and 10, just the integers. And then we're going to say that A, B, and C are subsets of the numbers 1 to 10. Okay. We have complements, which are everything that A is not. So A is these terms. So its complement would be these terms. Intersection is what they have in common. Well, what do A and C have in common? Just simply the number 8. Union is something that exists in one, the other, or both. So I started this one for you by saying that 1, 2, 3. If you notice, 4 doesn't live in either of them, so it's not part of the union. 5, and then see what you can do to finish that off. Okay. Little note, subset versus proper subset, maybe when you looked earlier. Subset could possibly be equal to the original set, but a proper subset is definitely different than the original set. So if you want to make a connection, you could say this is kind of like greater than or equal to, and this is just greater than. So kind of a similar thing to think about with the lines, but don't connect that too much together.